For billions of years, our sun blazed away merrily in the sky, watching over the Earth and making life possible with its light and warmth. But all stars eventually run out of fuel, collapsing into dense, hot remnants known as white dwarfs. And although astronomers have long believed that any planets orbiting these stellar corpses would be frozen solid, a recent study published in the journal Nature Astronomy suggests that these worlds may not be as dead as they thought. What's more, some of them could even be warm enough to support life. So buckle up, space cadets. Today we're exploring a strange new world where frozen wastelands might be hiding a bubbling undersea world. Our story begins with a journey into the heart of a star, a place where hydrogen gas reaches millions of degrees Celsius, fusing into helium and releasing tremendous energy. This fusion keeps the star shining for millions or even billions of years, but eventually the star runs out of hydrogen and it collapses under its own gravity. Without the outward push from nuclear fusion, the core contracts, heating up the surface and blowing off the outer layers. Once the star has used up most of its available fuel, all that's left is a hot, dense core made mostly of carbon and oxygen. These stellar corpses, known as white dwarfs, are incredibly diverse, ranging from just a bit bigger than Earth to several times its size. But despite their compact size, don't be fooled by their deceptively small appearance. Some white dwarfs can have masses as great as 10 Earths. As the star slowly cools down over billions of years, the surface temperature of the white dwarf decreases from thousands to hundreds of degrees Celsius. At this stage, they become very faint, losing most of their luminosity, which makes them extremely hard to detect against the backdrop of their much brighter stellar neighbors. Over time, they fade even further, becoming so dim that they can no longer be seen with the naked eye. The faintest white dwarfs are often mistaken for failed stars or brown dwarfs. As for any planets that happen to be orbiting these aging stars, they receive far less light and heat. Astronomers had assumed that these planets would be frozen, solid, locked in an eternal ice age with any hope for life long extinguished. But new research suggests that things might not be so simple. Now, let me introduce you to the odd case of WD-1856b, one of the first planets ever discovered around a white dwarf. It's roughly the size of Earth and orbits its star every 11 days, which is really close in astronomical terms. When it was first spotted in 2016, astronomers estimated its surface temperature at a frigid minus 350 degrees Celsius. That's almost certainly frozen enough to lock any potential life beneath a thick layer of ice. However, some scientists started to question this seemingly doomish forecast. They proposed that something called the greenhouse effect could be keeping the planet's core molten despite the frigid surface temperatures. In other words, there could be enough heat inside the planet to keep a small sea of lava bubbling beneath the ice. Now, you might be scratching your head wondering how that's even possible. Well, let me explain. When a planet is tidally locked to its star, one side always faces the star, and the other remains shrouded in darkness. On WD-1856b, the day side experiences scorching temperatures, while the night side plunges into chilling cold. This stark contrast creates a temperature gradient from the poles to the equator. Heat flows from the poles to the equator through powerful winds. As these winds move, they carry energy across the planet. If the atmosphere is thick and efficient enough, this energy can warm the far side of the planet, preventing it from freezing completely. To investigate this intriguing idea, a team of researchers led by Dr. Boris Safardi of the Institute for Advanced Study in Princeton turned to computer simulations. They developed a sophisticated model that simulates the atmosphere of planets around white dwarfs by feeding different atmospheric compositions into their model. They could see how well the heat from the day side flowed to the night side. Their goal was to find the right mix of gases that could create a cozy microclimate on the night side. The team's initial attempts at recreating such a scenario failed. Their simulated atmospheres either froze over too quickly or were unable to distribute heat effectively. However, after tweaking the model with carbon dioxide, they achieved success. By increasing the amount of carbon dioxide in the atmosphere, they observed a remarkable transformation. A stable temperature gradient emerged with the night side of the planet maintaining a toasty 100 degrees Celsius, more than enough to keep water in a liquid state. These findings were later backed up by a separate team led by Dr. Ramses M. Nakost at the University of Toronto. They arrived at the same conclusion that if WD-1856b had a carbon dioxide-rich atmosphere, it could maintain a hospitable environment on the night side. While the discovery raised hopes for life on planets like WD-1856b, the reality turned out to be a bit more bleak. Further observations revealed that the planet's atmosphere was primarily composed of hydrogen and helium, lacking the necessary carbon dioxide to trap heat effectively. As a result, the discovery of liquid water on WD-1856b faded into a distant dream. However, this setback proved to be just a temporary detour in the search for extraterrestrial life. After all, one planet doesn't make a trend. Scientists knew that there had to be other planets out there with more suitable conditions. The question was, where do we start looking? The answer came when NASA launched the planet-hunting Kepler Space Telescope in 2009. It was designed to systematically scan the stars in a small patch of the Milky Way, searching for tiny dips in their brightness, which could indicate the presence of transiting planets. But Kepler did more than just discover thousands of It also identified a number of fascinating systems that hinted at the possibility of life beyond our world. For example, Kepler 62f was discovered in 2014, and it immediately captured the attention of scientists, because it's about twice the size of Earth and receives roughly the same amount of light and heat as our planet. It orbits a red dwarf star, which is smaller and cooler than our Sun. But because it's slightly larger than Earth, it could have a liquid water ocean. Unfortunately, because it's so far away, about 1,200 light-years from Earth, observing Kepler 62f's atmosphere to confirm the presence of water or signs of life is beyond our current technological capabilities. However, another planet found by Kepler, Kepler 44b, offers us a unique opportunity to peer into the atmosphere of a planet outside of our solar system without the need to send a spacecraft to visit it. That's because, unlike most other exoplanets, which orbit their stars in a flat disk, Kepler 44b has an extremely eccentric orbit that brings it super close to us. About once every 2 years, this hot gas giant swings within just 2.5 light-years of Earth. The closest exoplanet will come this close to Earth for a few weeks, and then zoom back out into the farthest reaches of its orbit. And when it does, it passes in front of its host star, allowing us to observe a rare transit event. During these rare events, the planet's atmosphere is briefly illuminated by the starlight, casting a rainbow of colors through its various chemical components. By analyzing the spectrum of these colors, astronomers can determine what part of the light spectrum gets absorbed by particular chemicals, giving us a glimpse into the planet's atmospheric makeup. And in 2021, researchers eagerly analyzed data from one such transit, hoping to detect telltale signs of water vapor in the planet's atmosphere. Although their analysis didn't reveal any definitive proof of water, they did uncover some fascinating insights. The atmospheric temperature was found to be a staggering 750 degrees Celsius, which indicated the presence of thick clouds that reflected a significant portion of the But here's the kicker. Unlike typical clouds, which usually form around Earth due to water vapor condensing into liquid droplets, the clouds on Kepler 442b are likely made of solid particles of iron and magnesium sulfide. Now, you might be thinking, gross. Why would I want to live on a planet with toxic clouds? But hold on a minute, because this discovery opened up a whole new way of thinking about planets like Kepler 44b. Most astronomers assume that when it comes to habitability, you want your planet to be as Earth-like as possible. But this discovery suggests that planets with drastically different conditions from Earth could still be habitable. Just think about it. If organisms on Kepler 44b have evolved to thrive in the presence of iron sulfide clouds, who's to say that similar creatures haven't evolved around white dwarfs? So with this newfound perspective, the hunt for life began anew. This time focusing on planets orbiting those faint stellar corpses. And it was you and I, just a bunch of astronomers sitting around drinking space tea and gazing at the cosmos. No, they took action. One notable mission is the Berkeley Institute for Data Science's Planet Hunters project, which harnesses the power of crowdsourcing to analyze data from the aforementioned Kepler Space Telescope. Since its launch in 2009, Kepler has discovered thousands of exoplanets, many of which are potentially habitable. But with so much data to sift through, astronomers can't possibly analyze every single observation. That's where the Planet Hunters project comes in. By enlisting the help of online volunteers, the project aims to speed up the process of identifying potentially habitable planets. Participants can examine data and images, searching for patterns or anomalies that might indicate the presence of a planet. Then they can submit their findings to researchers who can follow up with further investigations. This approach has already yielded exciting results, including the discovery of Kepler 442b, which I mentioned earlier. The project has also helped confirm the discovery of many other exoplanets and has even uncovered some potential that is evidence of life in distant worlds. But the true value of crowdsourced astronomy goes beyond just the scientific discoveries. It also helps to engage the public in real scientific research, fostering a sense of wonder and excitement about the universe. Who knows, you might be the next person to stumble upon a groundbreaking discovery. While exploring the vast expanse of space from the comfort of your own home, the Planet Hunters project is just one example of how the search for extraterrestrial life is constantly evolving. As technology advances and our understanding of the universe grows, we continue to refine our methods and broaden our horizons. The discovery that planets around white dwarfs could potentially harbor life is just the latest development in this ongoing quest. With 10 billion white dwarfs sprinkled throughout our galaxy, the possibilities for finding life seem endless. The James Webb Space Telescope is already spotting planets around these ancient stars and helping us understand their atmospheres better. So who knows what wonders await us in the worlds around these icy wastes? Maybe there are oceans boiling beneath the ice, or maybe life has found a way to thrive in the most unexpected places. One thing's for sure, the search for life in the universe is far from over. And who knows, maybe one day we'll find that we're not alone. Thanks for watching. Remember, the universe is vast and full of wonders, and our journey to discover them has only just begun. If you enjoyed this video, please subscribe and join us in our quest to unravel the mysteries of the cosmos.